doing with the homework? I know, I feel that. Keep in mind, it's homework from a year's worth of general chemistry. So what I'm gonna do is print out a copy of the homework and give it to Miss Steele, and she can go through it with you. If you're not able to come to office hours when I'm here, she's here from 7 a.m. till 3 p.m. Monday through Thursday, and she's also here on Fridays, I believe, until at least noon. And I'm here all day on Fridays. So if y'all need refreshers or anything like that, she has all my stuff for general chemistry 1 and 2, and she'll also have a copy of your homework as well to be able to sit there and work with you. If you can't come in person, you can also do Zoom. She will Zoom with you if you need her to. So I just want to make certain that y'all know that that resource is available, and she's really, really good. She is really good. Okay, let's see. All right. Now we've gotten into hybridization and geometry of molecules. Let's see. Now we got to talk about isomers. Okay. Do you guys need more time to complete the general chemistry homework? Yes, no?
Yeah, I wouldn't complain.
You wouldn't complain? Okay, so what if, because I feel like since it is a year's worth of chemistry and these are things that you can refresh on throughout the semester, what if I extend that assignment just for you to work on throughout the semester? So that way, as we encounter where you need to reinforce those concepts, that will be good for you for practice.
What about that? There's one that's like 240 something concepts on there. Is that actually
Okay, so that was from your initial knowledge.
okay? I was like, I don't know that.
Yeah, no. Okay, so the initial knowledge check is kind of like the practice test that I gave you guys. So it can help you identify which areas that you're struggling with. So the algorithm can throw stuff in for you. Okay. Okay. So we've all decided as a class we're going to extend the general chemistry homework throughout the semester and use that to go back to as we need to hit the concepts that we need help with. And that Ms. Steele will have a copy of that. So you guys can go in and talk with her as those particular concepts come up within previous knowledge. So, okay, so the initial knowledge check, that also was supposed to see what knowledge you already have of organic chemistry as well. So if it's none, that's okay, because you haven't had the class before. So,
Can I just ask you one quick question? On the first test, are we gonna have like a section of general chemistry, or are you just gonna keep it like?
it will be primarily the things that we've talked about in class.
Okay.
Now, before you have a test, I will give you guys a quiz that you can work in groups together with to help prepare you for the exam. Y'all got that? Okay, because I found that the time that I've taught organic chemistry, students working collectively together, taking that unit 1 quiz, unit 2 quiz before we take a test, having that content, that was very helpful for them. So that's what I'm gonna try to do. So the goal is to master the concepts, not perfection, but to at least get, as many down as we can. So you can be successful in the class. Okay. All right, so let's talk about isomers. Different types of isomers. let's look at, when I type in different types of isomers, you get a whole myriad of different things. But I'm going to use our Master Organic Chemistry. This is another great resource. So we've got constitutional isomers, stereoisomers. We'll get into enantiomers and diastereomers a little bit later. So the objective for this one is identify isomers and explain the differences between them. So this gets more into detail when it comes to organic chemistry. But what I want us to worry about is constitutional isomers and stereoisomers. Constitutional and stereo. So what do you think of when you see stereo? We'll start with that one. What do you think of when you see stereo? I think of music usually. I kind of think of music. So let's look at, well, this is the biology. See, like biology. What? Hold on, I wanted the picture. I just want the picture. I don't want all of this. Go back. Here it is. I just want the picture. Open image in the tab. Here we go. Okay. There we go. So stereoisomers have to do with, it's put together similarly, but it's flipped or a mirror image. Stereo, but they're put together similarly. Constitutional means put together differently. So some examples. So we have structural isomers. And in this case, we've got fluorines on completely different carbons. We haven't gotten to Newman projections yet. This is also wedge and dash. We'll get into that here in a second. And here, we've got methyl groups on top and methyl groups opposite each other. So we can have flipped, where it's flipped on the same side or flipped on the opposite sides. And then we've got mirror image that kind of looks like hands. So if you take like, let's say this is bromine and this is fluorine. Fluorine is on this side and bromine's on that side. So our mirror images are enantiomers. Let's see. And then our flipped is our diastereomers. So we'll just make a note because we'll see that a bit later. And then this would be called, this is trans, and this is just essentially a mirror image, and we would use RS confirmation. We'll get to that later. Mostly, I want you to focus on these two. Stereoisomers, put together similarly, mirror image and flipped. Constitutional, put together differently. So let's draw out what these look like. So, constitutional. Constitutional. Could have C2H3OH, right? Or like say H4O, do it that way. H4O. So if I have a compound that's that, kind of like, there's different ways that I can put this together, right? That would be constitutional. So I could have C, H, 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 oh wait, hold on, I got 2 carbons. You do C, double bonded, carbon, HH. Oh, maybe this way, OH. 1, 2, 3, 4 carbon, 4 hydrogens, 2 carbons, oxygen, hydrogen, attached that way, right? What's another way I could draw this? Rearrange this. What do you think? I got my 2 carbons. What if I put, will a triple bond work there? No, we'll just keep it double bond here. But what if instead of putting the OH on this carbon, I put it up here? And then I've got H and H. Right? Is that the same? Well, it's the same number of carbons and hydrogens and oxygens and everything. But is it the same compound? No. These are constitutional isomers. Same amount of stuff being atoms put together differently. Okay, so that's the same amount of stuff. 2 carbons, 4 hydrogens, 1 oxygen, but it's put together differently. Which is why, when we do organic chemistry, we don't usually just go off of a formula like this, because this doesn't tell me where everything's put together. So that condensed version of, like this, would be CH2, CHOH. That would be the condensed formula of that. That tells me what this is, right? So this one, how would I write this one? I've got that H right there though, right? Yep. This gives me more information than just that, right? If I had to sit here, you know, one of the homework problems you might have is trying to do at least 2 or 3 different versions of what this could be, right? That would be the Lewis structures, trying to figure out the different ways you could put that together. Same amount of stuff put together differently. So the condensed formula lets me know what order my stuff is. Condensed formula lets me know what order my stuff is in. My atoms are in. We'll get more specific. right? Y'all remember that line angle formula? How would I do a line angle formula for either one of these? We'll do the top one. So I've got 2 carbons. So I've got 1, 2, that's it, 2 carbons. And then I've got a double bond between those carbons. So this carbon is going to have 2 hydrogens. And then I've got an OH here. We just feel like hydrogens matter, yes, but we're just going to imply it, right? So here I've got the CH2, I'm going to put the H2 on this side, double bonded to a carbon, which has a hydrogen. Well, I could just put CH. I don't even have to put that up there. Write it this way. CH, OH. That's what that means, essentially. So if we get a condensed formula, that's CH3, CH2, then we've got CH, so CH, CH. We could have something that looks like this, and then the CH3. That's a condensed formula. That tells me I got a CH3, CH2. You can write it out this way if I want. And then I've got a CH, and I got another CH, and I've got a CH3.
Gracious.
Yeah, but then I've only got 3 bonds here, so that means this is a double bond. Yes. Well, because I've got 1, 2, 3, 4 bonds. That's a fair question. So how would I draw that as a line angle formula? 1, 2, 3, 4, 5. I got 5 carbons. Every end and bend. 1, 2, 3, 4, 5 carbons. On that 3rd carbon, between the 3rd and 4th carbon, got a double bond there.
Wait, how do you know that that particular carbon has a double bond?
I'm counting my carbons from left to right.
Okay.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to be important, count carbons. And the direction count is important too, but for now, we're just dealing with nothing but carbons and hydrogens, right? These all mean the same thing. So this tells us more information than 1, 2, 3, 4, 5. Then C5, 3, 5, 6, 7, 10, H10. Right? Write all of the different ways you can put this together. Ms. Williams, I hate you. Don't do
Yeah,
that.
if you could just do that on the test, I would be great. Give us a test on that.
You worry about your carbons. See, the hydrogens here are implied. This one has 3. This one can only have 2. It's all right. This one can only have 1. So if I wanted to, I could put the hydrogens in. But when you're dealing with something like a lipid, where you have like 25 carbons, do you really want to write that out? Or write that out? When you can just go, you know what I mean? Then you can go, okay, hydrogens are there. We know that if there's a double bond, these carbons can only have one of them, one hydrogen. Single bonds, that carbon in the middle can only have two hydrogens. And carbons can only have three. So we can look at the pattern there, right? Let me show you. Let's look at some. There's, oh gosh, what was the name of that website? There's a drug database. Maybe if I spell drug right. Where is it? No, here we go. I think it's drug bank. Browse. I'm going to search. Let's look at chemical structures. Let's look at drugs with, what kind of medicine you want to look at? Which one? Metro. Metro di.
It's metronidazole.
Metroizanol. NIDDOZOLE. And O is in R. Here we go. All right. Let's look at that drug. So, trichomoniasis, so rosacea, bacterial infections, and prevents post-operative infections. So let's look at this. All right, so here's the structure for this. This is a line angle structure. We can look at it in 3D. Ah, yay! Here's the ball and stick model. Isn't that cool? So here's the ball and stick model. I have little model kits. If we wanted to sit and build these molecules together, we can. But here, you can look around here. What do you think the different colors mean? Yeah. Different atoms. We've got double bonds here, single bonds. So as we move through the course, you might see compounds represented in this form. The gray ones are carbon, white ones are hydrogen or less gray. Sometimes carbon is represented as black. Then we have nitrogen as blue and oxygen as red. If you're colorblind, this can be a problem. There are colorblind options on various websites to where you can alter them. But line angle formulas are usually very useful because there's our nitrogens, there's our oxygens, every end and bend is a carbon. So, how many carbons are in this image, do you think? 6. Here's 6. Yeah. 1, 2, 3, 4, 5, 6. Hey, that's cool. So what would be the formula if it looked like this? 6 carbons, 3 nitrogens, 2 oxygens. How many hydrogens? Well, 1, 2, 3. We got 1 hydrogen there. This one doesn't have any hydrogens. 1, 2, 3. It's got 4 bonds. That one doesn't have any hydrogens. 3, 4, 5, 6, 7, 8, 9. Yeah, I do this all day. So yeah.
You also know that. I just don't understand why there wasn't one where you said there wasn't.
So right here, this carbon is attached to 1, 2, 3, 4 bonds.
Okay.
So there's no hydrogen there.
Okay, I see.
No hydrogen there. It's okay.
I got you.
Into every end and then there's a part, right?
Yes.
So, but if there's like a nitrogen or oxygen, then there's no carbon.
There's no carbon.
Okay, that's what keeps throwing me off.
Oh,
Is like I thought.
that's fair. That's a fair question. So there's no carbon here, just oxygen. I think I had the same question when I was in organic.
So like with the carbon right there on the corner,
Mhm.
so each corner that's attached to that would be a carbon.
Yes,
And then when that one breaks off to the nitrogen, there's not one.
there's no carbons there. That makes sense. So isn't that easier to try to sort out than having to write something? Can you want to write it in that form? So we get to this portion real quickly. So drugs have what we call active sites, where they interact with the cell, like the receptor of the cell. Where do you think the active site would be on this particular one? We got this going on. We also have this going on. There are multiple places within a receptor that can interact with the medication. So what happens is whenever this medication is taken, for whatever reason, the receptor that it interacts with this portion of the medicine. So it can either shut off that receptor, block something else from getting into it, or turn it on. And that's how it does it. The shape of the molecule and those little sites. Isn't that amazing? Something that small can do stuff. So yeah, that's why what you're doing is important. Because we're learning about the stuff that turns on and turns off receptors in the medical sense. And then when you consider, if you go into like agriculture, pesticides that only work on specific types of bugs.
They have a test them out for, where they can take the DNA and then they can match it to medications that work with you and medications that do not.
Yeah, did y'all know that people who are descendants of survivors of the Black Plague have a natural immunity to HIV? Did you know that? Specific presence of a particular gene, because there's a certain receptor that's on your T cells that allows the HIV to attach to the T cell to infect it. It's not there on survivors of descendants of survivors of the Black Plague. You know how they found that out? Bone marrow transplant from one person to another who had leukemia because they were immunocompromised from HIV infection. HIV went away. Unfortunately, leukemia didn't, but completely gone, no more infection of HIV. Because all the T cells they were generating from the bone marrow transplant lacked that receptor to allow the HIV into it. Isn't that a thing? Small little thing of whether or not there's a receptor on a cell can change somebody's life. So that is how we do line angle type of diagrams. So let's maybe practice. Y'all want to practice some drawing line angle diagrams real quick? That's nice. All right, how about I just do this? Examples of organic chemistry compounds. You're just going to get a list. Really? There we go. Okay. Organic compounds. All right. Are we going to have actual names, or are we just structures? Hydrocarbons, let's just go there. Okay. I want the names, saturated hydrocarbons, for the formulas. The formulas, actual formulas. All right. Well, how about this? We'll do the reverse. You guys write the condensed, this version of the line angle formula. Here's 2-methylbutane. What's the condensed version of this? That's this one. So we've got CH3, CH, how many? So for one that looks like that. Huh? So we got 1, 2, 3, 4. That's CH3. Sometimes they put the carbons there. All right. So we've got, I'm just going to start here, CH3, CH2. So this has got one carbon. So that'll be CH, CH3, CH3. Oh, hold on. CH3 is attached to that one. So what did I do here? So these two are attached to this carbon. So I put these in parentheses because I have 2 of these that are attached to the same carbon. So they're CH3, CH2, CH, CH3, 2. So that one is here. That one is here. This one is there. And these two, I'm just going to put a little star right there. Y'all see that? Kind of, maybe, sort of.
So is the CH2 those first, like, connected to the CH3? Okay.
Yes, I tried to draw arrows.
Okay.
So this one is here.
And you said because it's a single bond, it has 2 hydrogens?
Yes,
Okay.
this carbon is attached to these 2, so it makes 4 bonds.
Okay.
That might take a minute. Let's look at a different one. All right, decane. That's not real. All right, I'm gonna erase over here. Decane. Are you seeing any, patterns with the names maybe? It's like everything is intentional in a lot of organic chemistry. The very name can tell you exactly what you're dealing with. Where have you seen DEC before other than December? That's it, dodecahedron, decahedron 10. There's 10 carbons there. Prefixes, we'll get to those though. So we've got, so that's essentially CH3, 1, 2, 3, 4, 5, 6, 7, 8. I got 8 of these. Right? If I want to, I can put the CH3 there. It's not necessary, but, you know. That's so much easier than, you know. CH2, CH2, CH2. So there's two hydrogens on here. Hydrogen, 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 hydrogen. I could fill all those in. Because this is a carbon, since carbon makes 4 bonds. That's
I
a,
just said that.
it's all right. I say things out loud to myself multiple times because sometimes I learn certain things backwards and I have to check myself.
Okay, so the 22 hydrogen, right?
So we got 8 times 2 is 16, 17, 18, 19, 20, 21, 22. Mhm.
So when you say carbon makes 4 bonds, is that connected with what we did on, okay.
Yep.
That makes sense.
Carbon makes 4 bonds. If you can count to 4, you can be an organic chemist. It's a good start, because that's a lot of counting 4, right? Let's look at another one. Let's look at another one. Okay. Something. In octane, how many carbons do you think are there here to look at the prefix? 8, right? So a little pro tip. Prefix, number of carbons. Meth, F, pro, bute. This is where it's weird. That's 1, 2, 3, 4. Pent, hex, hept, oct, dec. Wait, known, I forgot known. Known is there. Then dec. Isn't that neat? So if something's methane, 1 carbon. Ethane, 2 carbons. Propane, propane accessory. Y'all watch King of the Hill. It's 3 carbons. Hank Hill is a fan of 3 carbon compounds. Meth, F, prop, butane, hex, F, ox, known deck. Ugh. Octane, 8 carbons. That's one way you can check and see how you're doing. So we'll get into more of the names, but this is kind of giving you a little bit of a hint on demystifying some of these words. Dimethyl, 2 meths, 8 carbon chain. Di means 2, methyl, 2 methyl groups, 8 carbon chains. We'll get there. We'll have more practice on that. So if I were to write the condensed structure of that, I mean, this is the full formula, C10H22. That doesn't tell me how it's arranged, does it? No.
So that's what we just did.
Nope, this is a different one. This one, if you notice, we've got the octane here, but we got stuff attached to it. So the octane is the same that we just did, but here on the
We just added.
4th carbon,
CH3s.
we got a CH3 here, and we got a CH3 here.
Wouldn't that change the number of carbons?
It sure does, but We're getting there. They're not part of the main chain, are they? They're offshoots. So we gotta recognize those are offshoots. So the condensed formula, real quick for this would be CH3. Wait, no, I'm doing it wrong. Do condensed formula. CH3, CH2, CH2. I got 2 of those. Then I've got C with CH3, 2 of those. Then I got CH2, 1, 2, 3, 4, 5. 5 of these. Then a CH3. So all I did, that's okay. So what I did is I went through, and I wrote my CH3 here. This is a CH2, this is a CH2. So I wrote that here. Here's this carbon. And I've got 2 of these attached to it. Y'all see that? Okay. Then I have a CH2, 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 CH2. 1, 2, 3, 4. 5 CH2s. Then I have a CH3. So I just pretty much wrote down what each one of these things are in a straight line. And when I had multiple ones of the same thing, I put them in parentheses. I did this all day. So y'all are just starting out. It's okay. It's okay. But the goal here is to be able to recognize where the carbons are and that hydrogens are implied. That's the goal for today. We will get to here. I'll just learn brand new stuff. So it's okay. All right. We'll be getting to this when we start naming hydrocarbons. Eventually, we'll get to where you'll be able to look at a name like this and know exactly what the structure is, just based on the words. It's a whole new language. So y'all are learning a new language, so be nice to yourself. Be nice to yourself. This stuff is hard. Okay, and we know about Miss Steele. She's gonna have a copy of your homework. She's really nice. So you can come see her if I'm not available or if my office hours are not working well for me. Okay? Well, I'll let y'all go. It'll be all right. You're doing a good job, even if it doesn't